Hello, good morning, dear students. How are you, children? Children, today we are going to study the next topic, that is solution. Okay? In previous video, children, we have covered up to the topic types of mixture. Okay? Children, solution is also a mixture. Clear? It is a homogeneous mixture of two or more substances. Clear? First, you have to understand what is homogeneous. Children, when we are going to mix one component into another, okay, if both components dissolves completely, mix uniformly, that is known as homogeneous. And the property of homogeneous will be everywhere same. Clear? So children, we can write the definition. A solution is a homogeneous mixture of two or more substances. Since it is a mixture, children, that is why it is a made up of two components. The first is solute and second is solvent. Okay? Now let us understand what do the term solute and solvent mean. Clear? Solvent. The component of the solution that dissolves other component. Okay? That is called solvent. Note in copy, children. The component of a solution that dissolves other component that is called solvent. And generally, children, it is found in larger quantity. Okay, generally it is found in larger quantity. Now see, solute. The component of the solution that dissolves in solvent, okay, which dissolves in solvent, that is called solute. It is found in smaller quantity. Okay, children. For example, when we take two components, the first is water and second is sugar. Water always take in a larger quantity and sugar crystal always take in a smaller quantity. So when we add sugar in, children, this is a sugar crystal. When we add sugar crystal in water, after a while we observe that the component of sugar and water mix uniformly and gives a solution. Okay? Now here water will be solvent because it dissolves other component and also found in larger quantity. Sugar will be solute because it dissolves in the solvent and found in the smaller quantity. Clear, children? Therefore, children, we can write sugar is solute, water is solvent, and when they will mix with each other, they give sugar solution. Now, children, note in your copy, a solution in which solute particles are very small size, that is diameter of the particles less than 10 to the power minus 9, that is called true solution. Okay children? If the particles of solute are very small, means the diameter of the particles less than 10 to the power minus 9, that solution is called true solution. Okay? Now children, sometimes students got confused that here sugar is found in solid state, solvent always found in liquid state. Okay, so we can easily separate the solute and solvent from the solution. We can easily identify the solute and solvent from the solution. Is this happening in all? No. The solution can be too liquid also. The solution can be too solid also. Okay, let us take an example to understand this. Now children, look at these examples. First, second, third. These all are form solution. Okay. The first is sugar solution. So children, you can easily identify which is solute and which is solvent, because water dissolves the sugar in it. That is why water is solvent. Sugar dissolved in the solvent, it means sugar is solute. Here sugar is in solid state, water is in liquid state. But children, I have discussed that solution can be too liquid also and solution can be too solid also. Now the question is, how can we identify which is solute and which is solvent? So, in order to understand this concept, you have to learn that which quantity is much more than other. Okay, it depends on the quantity of their components. If the quantity of the component is much larger, that will be solvent. If the quantity is smaller, that will be solute. Now children, see second example. If ethanol, which is found in liquid state, 20% ethanol is added in 80% water. Okay, both are in liquid state children. It is also liquid, it is also liquid. So children, how can we identify which is solute and which is solvent? So children, if there is a two solution which is in liquid form, then you have to identify by their quantity. Now, water is found in larger quantity, so it will be solvent. Solvent will be water, and solute, that is ethanol. Because water is found in larger quantity, solid ethanol is found in smaller quantity. Clear children? Now third, alloy. Alloy is a mixture of two non-metal, metal and non-metal. Okay. So children, here one alloy is given there, bronze. Bronze is the combination of two metal. The first is copper and second is tin. Copper contains 80% and tin contains 20% by mass. Now we have to identify which is solute and which is solvent. Dear children, copper is found in larger quantity, so it will be solvent. Now our solvent is copper and solute is tin. Clear children? See children, characteristic of solution. With the help of its example children, we can easily know what are the characteristics of the solution. Okay. Look at this example. Sugar solution. You all know it very well that there are two components, sugar and water. When they mix with each other, they form a sugar solution. Now children, by their observations, we will find out the characteristic of solution. The first, it is a homogeneous mixture because two components mix uniformly. The first is it is a homogeneous mixture. Second children, the particles of solute means sugar are very small and less than 10 to the power minus 9. Clear children? Now, solution is stable. It means the particles of solute, okay, do not settle down in a solution, in a water, because it is already mixed with the water. So children, a solution is stable. Fourth, the property of solute are retained in solution. Children, it means the property of solute will be same everywhere in the solution. For example, if we are taking solute, that is sugar, which gives sweet taste, so when it dissolves in water, it again start giving sweet taste. Okay, the taste of sweet will not change when it mixes with water. Okay, now one also property is there children. The particles of solute are very small, then they cannot filter. Okay, they cannot easily separate by filter paper. Okay. A solution is transparent to light, okay, and does not scatter light because of very small particles. Means if a beam of light is passed through, suppose this is a light source, if passed through this solution, then the beam of light will not scatter. It means we are not able to see the particles, the size of the particles, okay, because the size of the particles are very small. Okay, clear children? Once again I repeat, if we pass light source in the solution, so we cannot see the path of beam of light because the size of the particles are very small. Clear children? Okay. Now children, concentration of solution. Before some time, you have seen that in solution there are two components. The first is solute and second is solvent, and both are therefore concentration of solution. It means how much of given substance mixed with another substance. Okay, the concentration means when we are going to mix one component to the other, so it tells how much of a given substance mixed with another substance, that is called concentration of. So it can be expressed in two ways children. The first is mass by mass percentage, okay, and second is mass by volume percentage. Now children, we will understand and also solve the question numerical on the basis of mass by mass percentage. Clear? See children, mass by mass percentage means we have to take the solute in terms of mass and also solution in mass. So we can write the formula: mass of solute on mass of solution into 100. Okay children, this is mass by mass percentage. Solute and solution both we have to take in mass. Clear? Now see the example children. A solution contains 40 gram of common salt, okay, in 320 gram of water. Calculate the concentration in terms of mass by mass. Solution. Children, mass of common salt is there. Mass of common salt 40 gram. Mass of water equal to 320 gram. Now calculate concentration in terms of mass by mass percentage. So we have the formula, children. Mass of solute, mass of solution into 100. See children, common salt is solute, okay. Water is solvent because it dissolves the common salt in it, and also the quantity of water is more than common salt. Now solution will be mass of solution, okay. Mass of solution is equal to solute plus solvent. Solute is 40 gram, okay, and solvent is 320 gram. Now the mass of solution will be 360 gram, okay. Now mass by mass percentage. Mass by mass percentage is equal to mass of solute on mass of solution into 100. Mass of solute is equal to, see children, mass of solute is given 40. Mass of solution is given 360 gram into 100. Okay, 0 cancel, 4 9 gram. So 11.11%. Easy children. Second, mass by volume percentage. It means mass of solute will be in mass and solution you have to take in volume. Okay. So the formula is mass of solute upon volume of solution into 100. For example, children, if 40 gram of hydrochloric acid is present in 100 ml of solution, it is given in volume, children, and it is given in mass. Okay. Now calculate its mass by volume percentage. So children, solution is mass of HCl equal to 40 gram, children. Volume of solution equal to 100 ml. Okay. Now calculate its mass by volume percentage. Mass by volume percentage. Formula is mass of solute means 40. Volume of solution 100 into 100. 100 will cancel, 40%. Easy children. Now children, the next is suspension. Before knowing differentiation between children, look at this example. When we add chalk powder in water, what do we observe? We see that the chalk, when dissolved in water, do not mix with water completely, and due to gravity it settles down at the bottom of the water. Okay, so it is a heterogeneous mixture because both components do not mix with uniformly. So this is called suspension. Okay, suspension word comes from suspended, means which do not mix and suspend at the bottom of the solution. Sorry, mixture. Okay, a heterogeneous mixture which contains very fine particles of solute, okay, and the size of the particles which contains fine particles of solute means the diameter of the particles of solute is greater than 10 to the power minus 6 meter, okay, and dispersed throughout means it will spread in everywhere without getting dissolved in the solvent, okay. So we can see chalk and water. When it dissolves in water, it spread everywhere in water and gets settled down at the bottom of the water. The particles of the chalk will be greater than 10 to the power minus 6, and these particles are visible to see. Okay. Properties of suspension. Okay. See the example, children. Chalk and water. When chalk mixed with water, okay, it does not mix uniformly and settle down at the bottom of the water. This topic has been explained. Now with the help of these children, we can find out the properties of suspension. The first, it is do not mix with uniformly. So children, this mixture will be heterogeneous. Second, chalk, after mixing of chalk with water, we are able to see the particles of chalk. Okay, it means the size of the particles of chalk greater than 10 to the power minus 6 meter. Okay, 10 to the power minus 6 meter. The particles of suspension do not pass through the filter paper because the size of the particles are more. That is why they cannot pass through the teeny pores of filter paper and can be separated out. Fourth, the particles of suspension settle down under gravity. Means the lighter particles will disperse in everywhere, spread everywhere in water, but heavier particles of suspension will settle down under the gravity. A suspension is not transparent to light. Okay, clear children? Very easy. Transparent means when a beam of light passes through the suspension, the particles of suspension can be easily seen. Okay. So another mixture is colloid, children. It is also mixture in which the diameter of the particles intermediate between that of true solution and suspension. Means a mixture in which the size of the particles is greater than true solution but smaller than suspension. That is called colloid. The example of colloids are milk, blood, smoke, etc. See children, colloid mixture is look like a homogeneous mixture, but it is actually a heterogeneous mixture. Okay, by their property we will see that how it is heterogeneous mixture. Clear? Colloid consists two phases. The first is dispersed phase and second is dispersion medium. In the same way, when you are using component in solution, the first is solute and second was solvent. Like that also, colloid contains solute and solvent. Solute dispersed phase, solvent is dispersion medium. Okay? See, dispersed phase. The component of colloid solution which is present is smaller proportion. Okay? That is called dispersed phase. And the component of colloidal solution which is present in excess, okay, found in larger quantity and act as a medium in which dispersed phase is dispersed. That is called dispersion medium. For example, when sulfur, suppose this is water, when sulfur mixture is added, so when sulfur is mixed with water, Suppose this is sulfur and this is water. Okay, the mixture of sulfur and water is colloid. Okay, so here sulfur is dispersed phase and water is dispersion medium, because sulfur is found in a smaller quantity, smaller proportion, and water is present in excess and act as a medium in which sulfur is dispersed. Clear, children? Now, with the help of example, children, we will see and we have to find out the properties of colloidal solution. Now see the properties of colloidal solution. Suppose, children, we have taken a milk in a glass. Okay. Now this is a colloidal. This milk it look like a homogeneous because the particles of the milk are very small. Okay. And our observation is that the particles, because there are many different particles are present in milk, fat, proteins, vitamin, okay, and they mix uniformly with each other. So it means we can say that it is a homogeneous, but no, children, it is a heterogeneous. It look like a homogeneous, but actually it is a heterogeneous. Now see, children, first it is a heterogeneous. I will explain this example on the basis of this observation. Okay, so the size of the particles is bigger than true solution but smaller than suspension. The particles of most colloid cannot be seen. The particles of colloidal can pass through a filter paper because the particles of this are very small. A colloid scatters a beam of light passing through it. With the help of these, children, we will say that how it is a heterogeneous mixture. Now, children, we have to experiment. First beaker contains true solution, means sugar solution, and second is colloidal solution, means soap solution, milk. Okay, you can take anything in colloidal solution. Any example, children? So when a light is passed through in true solution, being the size of the particles are very small in true solution, the path of beam of light are not visible to us. Means it will not scatter the light. That is why we are not able to see the path of beam of light. So it will be homogeneous mixture. Okay. Now when light, okay, it pass through in colloidal solution, due to having a larger size as comparison to true solution, this particles scattered light. These particles scatter light and make a path beam of light visible to us. Means we will know the path of beam of light, means where it passes through, children. This scattered light, the scattering of light is due to the size of the particles. Okay, this scattered light reflected in our eyes and makes a visible the particles, the size of the particles. Clear, children? Once again, this scattered light enter in our eyes and we are able to see the size of the particles in colloidal solution. But due to having a smaller size of the particles in true solution, it does not scatter light. That is why we are not able to see the path of beam of light. Clear? So, children, write the definition that the scattering of light by colloidal solution is called Tyndall effect. Okay, the scattering of light by colloidal solution is called Tyndall effect. That is why, children, colloidal solution is called heterogeneous mixture. Okay, and we can see children, true solution does not show Tyndall effect, but colloidal solution show Tyndall effect. Thank you children.